Okay, cool. Right, okay, so we're now going to be sketching the gradient functions. So we're sketching f dash x, so what the actual gradient looks like. So I think this is a very useful table to keep referring back to when you start getting into a muddle. Okay, so let's just hook out the key points and compare it to the two graphs on the right. So just take on board what's going on the right. The top graph is the actual function, okay? And the graph below is where we've actually sketched the differential function, where we're sketching the gradient function. So let's just think about the key points that they're making in the table. So where we have a maximum or a minimum, this is the bit in orange, we know that the gradient is 0. So therefore, wherever we have a maximum and minimum, I would suggest just start off and make the corresponding x value 0 on your gradient function graph. So that's the bit in orange. So straight away, there's a maximum or a minimum, and I've gone and popped in it crossing the x-axis where I've shaded in orange. Now, at a point of inflection, okay, the gradient is 0. It is still 0. But it doesn't change direction, does it? The example we've got here, the graph is still continuing to go downhill afterwards. So it's not going from being a negative to a positive gradient or a positive to a negative gradient. So it just touches the x-axis. It doesn't cross the x-axis. It's not going from being negative to positive or positive to negative. So any points of inflection you have, go and make a note of the corresponding points on the x-axis. But bear in mind, as you draw in your graph, it's going to be turning there, it will not be crossing. So just to recap, both the orange plate spot and the light blue spot, those coordinates are on the x-axis. But the orange one, the line crosses the x-axis. The light blue one, it just touches the x-axis. Now, moving on to the green line, wherever we have a positive gradient, okay, we know the gradient's greater than 1. So when we go and draw the differential function, the gradient function, by definition, that's going to be above the x-axis. I'm not going to refer to it in the table, but it's worth mentioning it now. Do you see how while it's going up, the gradient is going up, but it's at a decreasing rate. It's getting less steep, okay? That's why when you draw the gradient function, it's going downwards. It's getting less steep left to right, hence why it's going downwards. Right, and then moving on to the purple bits, wherever you have a negative gradient, i.e. wherever the line is going downwards, okay, obviously it's a negative gradient, so it's going to be below the x-axis, and whether it's going up or down depends on whether it's getting steeper or less steep going downwards, okay? So you've just got to gather your thoughts on that. So take the bit at the end, for example, that's getting steeper and steeper negatively. So that's why not only is it below the x-axis, but it's going downwards. Right, okay, so we don't have any asymptotes on this example here. Okay, those lines that they've put in is just to show us the corresponding points. They're not asymptotes. But just do bear this in mind. Where you have any asymptotes going downwards, then the asymptote remains unchanged. So you could just draw in the same asymptote on the gradient function. Where you have a horizontal asymptote, so just picture that, I might just draw this on the screen. So where you've got a horizontal asymptote, okay, and you've got some curve approaching it, well, obviously that curve is getting closer and closer and closer to being flat, isn't it? We're getting closer and closer and closer to it having a 0 gradient, hence why when you draw your gradient function, the horizontal asymptote is on the x-axis, all right? The gradient equals 0. That is approaching 0. So that kind of makes sense. So let's just look at a couple of examples. Okay, so we've got, well, we haven't clicked through, there we go. So we are looking at the function in the top left-hand corner. Okay, top right-hand corner, sorry. So that is our function. The diagram shows the curve with equation y equals f of x. And we've got stationary points at -1, 4, 1, 0, and -3, 0. Sketch the function. Okay, so start off by popping in the ones we know. So we know that at the maximum and the minimum points, so at -1, 4, and 1, 0, it cuts the x-axis. Okay, so let me just go and pop those on. And what colour shall we use? Let's use the light blue. Okay, so at those 2 points, at the maximum and the minimum is going to properly cut the x-axis. The bit that I've shaded in green, it is obviously a positive gradient, so it is going to be above the x-axis, but it's increasing at a decreasing rate. The gradient, while positive, is getting a smaller and smaller number. It's becoming less steep, hence why that bit in green is going downwards. And then the bit in brown is obviously a positive gradient again, so above the x-axis, but this slope is increasing at an increasing rate, hence why it's going upwards. Okay, so just try and be clear in your mind. Both the green and the brown are above the x-axis because they are positive gradients, but the rate of increase of the green one is decreasing, hence why it's going downwards, and the rate of increase of the brown one is increasing, hence why it's going upwards. Now that bit in orange in the middle, just think about it. It's going to be below the x-axis because it's going downwards, but it's getting steeper going downwards to start with, hence why the first part on the gradient function is going downwards. This bit here, that's going downwards. Can you just see that blue circle coming through? That's going downwards because we're on that part of the curve while it's going downwards at an increasing rate. Now, after that sort of after a while, it carries on going downwards, but it's getting shallower, hence why it's increasing at that point. So these do take a little bit of getting your mind around, in my view. You might find it easier than I do. Okay, and then there's just another. Don't think I'll spend so long pondering on this one, but I just wanted it on the recording. If you want to just play it back. Okay, so the green bit is going downwards, hence why it's below the x-axis, but it's decreasing at an increasing rate, hence why it's going upwards. And I think the other point to take in. So let's just think about we've got a horizontal asymptote in the function. So let's just mark that one. Okay, the horizontal asymptote in the function. So when we sketch the gradient function, our horizontal asymptote is at the x-axis. So I think that's really the key points to draw from this. So I'd like you to work through exercise 12J. I don't think it's a hugely big exercise for memory. No, it isn't. But I just think it takes a bit of thinking about it, so I don't want us to rush this. So while it's only quite a short little exercise, a couple of questions, I just wanted it to be, that's all we do today, okay? And then next time I see you, we can move on to modelling. Okay, so I'm just going to stop the recording. Once I've stopped the recording, you're obviously welcome to unmute and ask any questions you've got. And if you wanted to have your cameras on, of course, at that point you could have your cameras on. So let's just stop the recording.